Hi, and welcome back to Chapter 3. Today we'll be covering 3.1, which we can define what a matrix is. So as you see here, I've opened up RStudio already, but I'll be focusing primarily on the console where all the work is being done. So to quickly define what a matrix is, matrices store data in a two-dimensional array. You must pass atomic vectors to a matrix using the matrix commands. So you're going to use matrix, open and close parentheses, and you're going to input the variable there as you see on my example. Here you must also define how many rows the desired matrix should be, and you can also pass the encol argument to specify the number of columns. So we see here we have on the fifth example, matrix example 2D, matrix example is the variable, and then n rows equals 2 is the argument passed. The argument is singular, not plural. Many people make this mistake, as much as I do as well. It still catches me every now and then. Something I quickly want to touch upon though is a word here that you may not have seen thus far, which is the array. So what an array is, it's just an ordered series or an arrangement. So if you take a look at the first line that's in the console where it says initial vector example, you see C in parentheses 1 through 4. So C is going to be a collection of data. This is what is termed as the array. So just moving forward, the organization of a matrix can be modified with the by row argument. So you can organize it by row, or it defaults by column, as you see here. So notice that the Boolean value passed by row's argument for R is to fill the matrix correctly. Now these do have default values, so if you don't add it, it's going to go ahead and do that. By row, false. Depending on the type of data used, this can help organize the matrix to make certain comparisons or apply functions to that you'll see later on down the road. But it's very important to get the syntax and the notation correctly so you know where your data sets are going to fall within the matrix. So here's another example where we can see that it's no longer done by rows. You have an argument that you pass, which is encol, and you can go ahead and make it as many rows as the amount of data points that you see here. So the organization of matrices is important when trying to analyze data. You always want to ensure that the matrix is organized to suit the type of analysis required. So if you want to go ahead and multiply across rows or across columns, it's very important to know exactly where your data is and how it's structured.